Hello everyone, thanks for your interest in our project TapGazer, text entry with finger tapping and gaze-directed word selection. This is Zhenyi He. The project TapGazer was done in collaboration with Professor Christof Lutteroth from University of Bath and my advisor, Professor Perlin from New York University. Text entry is one of the most frequent, important, and demanding tasks in personal computing, since efficient text entry methods are essential to computing platforms. With the development of technology, the input device, modality, shape of the keyboard, and visual effects in the text entry area are changing accordingly and timely. In this project, we focus on immersive environments, starting with VR and discussing its potential for future AR scenarios. While using VR, efficient text entry is a challenge for quite a few reasons. Proximity. Users cannot easily locate standard physical keyboards in VR. They may walk, turn around, and keyboards are often out of reach. Mental visibility. Headsets stop users from seeing their hands and keyboards directly, thus it increases the difficulty of identifying which key is which. Lastly, learnability. Considering users, especially fast typists, are very used to certain keyboard layouts. For example, QWERTY keyboard. It is beneficial to maintain that muscle memory. We went through the literature to see how previous work deal with these challenges and investigate the ideas that could be feasible in VR scenarios, although they were not originally designed for it. The result was summarized into the table with the corresponding performance, a trend of work contributing to understanding which key users want to type from user behaviors. For example, TOE's leverage statistical decoding algorithm for 10-finger typing. Reduced keyboard is also a good fit for typing in VR since it reduced the keyboard from 26 keys to around 10 keys that could be handled by 10 fingers, like one-line keyboard and stick keyboard. Gaze detection is newly introduced into typing system because gaze operation is fast and intuitive. iSwipe and TagSwipe focus on heavily using gaze for text entry. Though relying on gaze for entering text is not optimal for performance, utilizing gaze as a modality alternative is very inspiring. Thus, we present TapGazer, a text entry system where users type by tapping their fingers without looking at it. Users can type anywhere as long as the identity of each tapping finger can be detected with sensors. Here is the workflow of TapGazer. A user is typing on her thighs using a tap strap device. Tap strap manages to report which finger is being tapped. Now the user started to type the word children. The interface provides optional visualization of the finger key mapping as a virtual keyboard and hand. The user first tapped the left middle finger, indicating letter C, and then the right index finger, then the right middle finger. Finally, the user looks at the word children, which gets highlighted with an underline as it is gazed upon, and taps the right thumb to select the highlighted word. To realize TapGazer, we have explored the design space of each component: virtual keyboard layout, word candidate layout, input device, and disambiguation. To begin with, virtual keyboard layout is the reduced keyboard layout that maps the user's fingers to the letters. From a pilot study, we find people had varying finger preferences for typing on the QWERTY keyboard. For example, letter M may be pressed with either the right index finger or the right middle finger. TapGazer creates a profile for each user to record their finger to key mapping, also allowing users to map multiple fingers to the same letter. Because each finger tap can be interpreted as one of several characters, the word represented by the input is ambiguous. We refer to a set of words that all have the same tapping input string as a homograph set. Secondly, word candidate layout. We initially designed several candidate layouts to see if the features like silence, continuity, and semantic location are positively correlated with typing performance. From the pilot study, our most important finding was that it is not beneficial to design the visual layout around the typing process or around cognitively demanding criteria such as relative alphabetic ordering, as fingers are much faster than the eye or the mind. It is more useful to consider the layout as a pure visual search task, where visual search time is correlated with the number of candidates and the distance of eye movement. So we provide a pentagon layout as the final design. It is comparatively narrow, so users do not need to scan the candidates forth and back horizontally. The distance between the corner of the closest letter of nearby candidates is based on gaze tracking precision. After presenting possible word candidates, users need to select a candidate to disambiguate the input. TapGazer takes advantage of this quick subliminal fixation by employing gaze tracking for word selection. Once the user has found the right word and is looking at it, the user can select it with a tap of the right thumb. We chose to use a tap rather than a gaze dual for selection, as the latter is much more time-consuming and can lead to midas touch. We designed a variant of completion mode for TapGazer. We show incompleted words when word completion mode is on. Otherwise, we only show complete candidate words. In the absence of gaze tracking, we provide a variant of TapGazer with purely manual selection. For evaluation use, we have prepared several input devices that support reporting finger identity. A pair of sensor-morph touchpads are used for seated via scenarios. A pair of touch-sensitive gloves that report taps with finger identities are used for on-body typing. Also, we support deletion, entry of unknown words, symbols, and cursor navigation by allowing users to switch between different modes. Then, we conducted two-user study to examine how TapGazer with different completion variants perform in terms of speed, accuracy, and user preference, as compared to typing on a physical QWERTY keyboard outside of VR, and how typing on the thighs in different poses, including sitting and standing, impacts TapGazer performance. Results show that seated novice users using touchpads as tape surfaces reached 44.81 words per minute, 79.17 of their QWERTY typing speed. Only the main effect of session is significant. Regarding completion variance, 10 out of the 14 participants preferred word completion. After calculating how participants can take advantage of word completion mode, it shows using word completion could theoretically have saved up to 34.2%, but participants use the word completion mostly only for long words. In the second study, users tapped at 47.16 words per minute for sitting and 45.26 words per minute for standing. Now, let's discuss the limitation, open questions, and future work. Regarding design, word prediction is based only on word frequency right now. It could be improved by also taking the context into account. We also do not provide autocorrection, as this could confound our study of accuracy, but this should improve the accuracy a lot for typing system. We need to admit that the use of gaze in TapGazer is not only the main strength, but also likely its biggest limitation. Besides typical challenges of gaze tracking such as availability and accuracy, users of TapGazer need to use their gaze while typing, which makes eyes-free typing infeasible. Regarding user study design, our study used a novice and is mainly cross-sectional, thereby likely underestimating the average performance of long-term users. Also, both evaluations had fairly small sample sizes. Lastly, it still remains an open question that is it a good idea to disregard finger positions altogether, although they were shown to be beneficial to input speed when typing on hard, flat surfaces. In the future, when affordable AR glasses with gaze and finger tracking will be as ubiquitous as mobile phones are today. Various of those glasses may use TapGazer for text entry. For example, by typing on their thighs while waiting at a bus stop or walking down the street. This is an exciting direction for future work. Thank you very much. Any questions?